What's up, guys? This is part 2 of the introduction to polynomials in maths Olympiads. Let's get straight into it. So in our last video, we covered what the degree of a polynomial was. Now, among other things, obviously. Now we're going to be exploring the degree in more depth. So if you don't know what the degree of a polynomial is, go watch the last video. Hopefully it should clear up some things. But if you do understand what the degree of a polynomial is, then let's get straight into it. So the first property that we're going to be looking at of the degrees of polynomials is if we have f and g as polynomials. So f and g are both polynomials. Then, so if they're both polynomials, and we know that, the degree of f multiplied by g is equal to the degree of f plus degree of g. Okay, so let's unpack this a bit. So f and g are two polynomials, and what we're essentially saying is that when they're multiplied together, the degree of the product is equal to the degree of the sum of both of the individual polynomials. So, essentially, why this works or why this is true is because if you think about it, let's say that degree of f is r and degree of g is n. So essentially, what this means is that the leading term, let's call that L dot D, L dot T, the leading term of f is going to be something in the form ax to the power of r, and the leading term of g is going to be something in the form it's not necessarily the same, so let's call it b x to the power of n. Okay, and when we multiply these, since these are the leading terms, this is the greatest power of x, or n is the greatest power of x that there is out of all of the terms in polynomial g, and similarly, r is the greatest power of x that there is in all of the terms in polynomial f. So that means that, well, if we multiply the two leading terms together, or the terms with the two greatest powers of x, if we multiply those together, then we are going to get the largest possible, or the leading term of the polynomial formed from when we multiply those together. Because if you think about it, if this is greater than, or if r is the greatest exponent of x out of all of the terms in f, and n is the greatest power of x out of all of the terms in g, then when we multiply f and g together, there is only going to be one term, which is ab multiplied by x to the power of r plus n, and there is going to be nothing greater than that, because, well, if we decide to multiply ax to the power of r, which is the leading term of polynomial f, if we decide to multiply that by any other term aside from any term other than the leading term of g, we are going to get something smaller than r plus n as our power, right? Because n is greater than all of the other exponents that we have of x in that polynomial. You understand what I'm trying to say? So essentially, this is the largest power of x that we can form, and therefore it is going to be the leading term of the polynomial formed from the product of f, or the product fg. So since the degree of f is r and the degree of g is n, we can say that the degree of f times g is the degree of f, which is r, plus degree of g, which is n. So r plus n is the degree of the product fg. So, hopefully that made sense. That's the first main property we're going to be going over. The second one will be the degree of, let's use f and g again as our polynomials. So f plus minus g will always be less than or equal to the maximum or the greatest of the degrees of f and g. So in plain English, what this is the degree of the sum or the difference of two polynomials is always going to be less than or equal to the essentially the highest degree of both of the polynomials. So again, let's say degree of f is r. Did I say that was r? Yeah, I did. Degree of f is r. Degree of g is n. Is it n? Yeah, it is. And let's just assume that r is greater than n. This means that when these two polynomials are added or subtracted to/from each other, then, well, the degree of the result of adding or subtracting them or the polynomial that we get from adding or subtracting them, the degree of that is just going to be the larger one of the degrees of f and g. So since the degree of f, which is r, is larger than the degree of the degree of g, which is n, the degree of f plus minus g is going to be less than or equal to, well, we actually know that it's going to be less than, we know that's going to be equal to the degree of f, which is r. Apologies. I've had too many carbohydrates today. So, just as a side note, the reason I say that is because carbohydrates make me give me brain fog, if you know what that is. Sorry, I'm going off topic. So, the degree of f plus minus g is going to be the degree of f, since the degree of f is larger than the degree of g, and the degree of f is r, so we know that it's r. Now, the reason you may be wondering why there is a less than here. Well, the reason it's there is because we need to account for all cases if we want to use an identity, we have to use an identity that works for all cases, right? And so the only way that this works for all cases is if it's less than or equal to, because there will be in one case where, let's say that the leading term of f is ax to the power of n, and the leading term of g is ax to the power of n again. So both of if both of their leading terms are the same, then that means that both of their degrees are going to be the same. Let's walk through it step by step. So their leading terms are the same. So that means that if we do the degree of f minus g, in this case, it will have to be less than the greater one of the degree of f or g, right? Because if we're subtracting f from g, so f minus g, there are loads of terms in f and there are loads of terms in g, but it doesn't matter. If we're doing f minus g, then this ax to the power of n, so let's just say that's ax to the power of n, and g is same thing, ax to the power of n, then these two ax to the power of n's, they're going to cancel each other out. And since they're the leading terms, the n is the greatest power of x out of all of these other terms here, and same thing for here, which means that the result of that will be that we get left with a new polynomial with a degree that's less than n, right? Because it can't be the same as n, because well, n is getting cancelled here, and n is getting, like, it's just getting cancelled because we're subtracting them. And since they're the same thing, it just goes to 0, right? So if we say y minus y, if we call this thing here y, by the same logic, this thing here is also y. If we say y minus, it's just anything minus itself is 0. So it's just 0, and then it's going to be plus or minus like a bunch of other terms that are that we have like remaining in here. And since it's a leading term, there is going to be no power of x in this polynomial or this polynomial, which is going to be greater than n, meaning that the degree is going to be less than the or the degree of f minus, or the difference of the two polynomials is going to be less than the larger of the degrees of f and g. So those are our two main properties, and now we're going to go on to something a bit more interesting. This interesting thing, like question, is what is the degree of a polynomial p if p is a zero polynomial? If p is a zero polynomial. What a zero polynomial is just p equals 0. Okay, so essentially what I'm asking is, what is the degree of 0? Well, what I first thought when I learned about this was I thought that the degree of 0 is 0, right? Because I thought that, well, 0 is the same as 0x to the power of 0, and hence the degree of this is 0. However, if we assume that degree of 0 equals 0. If we assume that that's the case, then going back to our, I don't even need to go back to it, going back to the the identity for the degree of the product of two polynomials, well, let's say we have two different polynomials. Let's say we have polynomial r and g. Degree of r times g. Okay, let's say g is a 0 polynomial, which means that it's just 0, right? And by assumption, I probably shouldn't write that. By assumption, degree of g equals 0, right? Because well, we've assumed that the degree of 0 is 0 and g is 0, therefore we can substitute 0 into here to say that the degree of 0 is 0. You understand? So that's what we've assumed. We assume that the degree of g is 0, and let's say f is x squared dot dot dot, where x squared is the leading term. The degree of f, why did I put f? Sorry, g. No, r even. Okay. So the degree of r is 2 because I've specified that the leading term of r is x squared, meaning that the x squared is the largest power of x out of all of the other terms that we've got going on here. So yeah, degree of r is 2, degree of g is 0 by assumption. So our identity that we looked at earlier is the degree of the product of two polynomials, in this case r and g, is equal to the sum of the degrees of the individual polynomials. So this is degree of r plus degree of g. Okay, now r is 0, g is 0, so we can, if we put this around back here, we can say that the degree of, well, substituting 0 for g in there, we can say the degree of r times 0 is equal to, well, r is, it doesn't really matter what r is, because either way, this is going to be 0, right? Anything times 0 is 0. So this is equal to the degree of 0. So by that logic, if we know that the degree of r times g is 0, then we can say that degree of 0 is equal to this thing here, which is equal to the degree of r, which we've said is 2, plus the degree of g, which we've assumed is 0. Okay, sorry, I just had to think there for a second. So essentially, we've assumed that the degree of 0 is 0. So if we substitute that in to here, we get 0 equals 2 plus 0, which is it's a rather astonishing result. Yeah, it does not make much sense. So this cannot be true. So the degree of g, the degree of 0, I should say, doesn't have to be, it can be anything. The degree of 0 cannot be equal to 0. Okay, because we've just it just can't work, because 0 is not 2 plus 0. It just doesn't make any sense. So, yeah, going back to what we have here, we have degree of r times g, which is the degree of 0, is equal to the degree of g, which is 0, plus degree of r, which is 2. So, putting this into just making it a bit nicer, we get r times 0 is 0, so degree of 0 is equal to degree of 0 plus degree of r, which we've said is 2. So essentially, we need to assign some value to the degree of 0 such that, well, when we add something to the degree of 0, it's still equal to the degree of 0, and no normal number can do that. So have a think for a second as to what it could be. Well, it turns out that the answer is minus infinity. So degree of 0 is minus infinity. Because, well, minus infinity is equal to minus infinity plus 2. But 2 is negligible, so it doesn't really matter, because negative infinity is so big that it's equal to... Infinity is a weird thing. Just know that the degree of 0 is equal to negative infinity. And you may be wondering why it can't be positive infinity. So let's assume that the degree of 0 is positive infinity now to prove that it can't be. So now assume that the degree of 0 equals positive infinity. To disprove this, we're going to use our second identity that we covered, which is one of addition and subtraction. So if we have two different polynomials, let's say we have polynomials, what letters haven't I used? So you have polynomials h and j. H and j are polynomials. Okay, let's say h is x squared and j is negative x squared. So by our identity for addition, we're going to get that the degree of h plus j is less than or equal to the maximum degree, or essentially the largest of the degrees of h and j. Okay, so the larger degree out of h and j, well, the degrees of h and j are the same. They're both 2, right? So it doesn't really, so either way it's going to be 2. So degree of h and j is 2, therefore this thing is 2. So we know that 2 is greater than or equal to the degree of h plus j, which is x squared, plus minus x squared, which is 0. So let's write that out so you can see it more clearly, which is equal to degree of x squared plus j, which is actually minus x squared. Right, you got plus and a minus. Plus is irrelevant, it's just minus. These two cancel out, which gives degree 0. So we know that degree 0 is less than or equal to 2. So if we, well, by assumption, the degree of 0 is positive infinity, so we come to the second astonishing conclusion that positive infinity is less than or equal to 2. Yeah, that doesn't seem very convincing, does it? So the only option that makes sense is, well, this is wrong. The only option that makes sense is negative infinity. So yeah, hopefully you enjoyed the video, you found some value in it, you learned some stuff. That's it for this video. Come back for part 3. In part 3, we're going to be going over... What are we going to be going over? We're going to be going over multiplication and division of polynomials. So, yeah, see you then. Bye-bye.